this part I'm just going to show you. When the function is multiplied with a constant, how will we find the derivative of x to the power n? That means 5 times x to the power 7. How we find out the derivative? Actual definition of derivative is limit h tending to 0 f of x plus h minus f of x upon h. F of x is x raised to 7. So f of x plus h will be 5 x plus h raised to 7. That is, in place of x, it will be x plus h. So 5 will be taken common. That 5 will come outside the limit. And you know already that how to calculate limit of this. It is nothing but 7 into x raised to 6. So your answer become 5 times 7 into x raised to 6. So if I want to find out the derivative of 5 into x raised to 7, what should I do with this 5? The 5 will remain the same in the same position, and you need to calculate the derivative of x raised to 7. So directly I can write 35 x raised to 6. So now you tell me, f dash of x, let's say 10x cube. So your f of x is 10x cube. What will be the f dash of x? 10 times derivative of x cube. A constant into a function. Constant will remain as it is, derivative of x cube. So it becomes 3x square. So your answer is 10 into 3, 30x square. Again, notice this. Let's suppose I write the function as, let's say, a times x raised to 10. What will be the derivative of a x raised to 10? Now remember, the function's variable is x, f of x. X is a variable. So a is a constant. A is like 10. There's no variable in a. So your answer will be a into 10 times x raised to 9. So I can write 10a x raised to 9. So any alphabet other than x present in it, that alphabet is a constant because the function's variable is x. F of x means a function in x. The variable is x there. So a is a constant. Suppose I give you f of x as, let's say, sine alpha into x cube. Find the derivative. Remember, function is in alpha x. So alpha is a constant. So f dash of x would be, sine alpha will remain as it is, 3 times x square. Derivative of x cube is 3x square. Let's try to understand one more thing. The function is, let's say, a cube x raised to 4. The variable is x there. So the derivative with respect to x, f dash of x will be a cube as it is, derivative of x raised to 4. That is 4x cube. So your answer is 4a cube x cube. Imagine the function is defined as f of a is equal to a cube x raised to 4. Now remember, a is a variable. So derivative of the function with respect to a, x raised to 4 will become a constant, and derivative of a cube will be 3a square. So how do you come to know which is a variable? The variable, whatever the bracket, whatever the alphabet is written, that is a variable. And f dash of that variable means derivative is with respect to that variable. So you can say a is the derivative. If you write f dash of a, derivative is with respect to a. If you write f dash of x, derivative is with respect to x. All other terms present there are constants. Example, I am showing you, if the two terms of x to the power are connected by an addition sign, plus sign, how can you calculate the derivative of that function? Just let's have a look. I put the definition of derivative. Limit h tending to 0, f of x plus h minus f of x upon h. This is the definition of derivative. F of x plus h means in this function, wherever x is present, replace it by x plus h. F of x is the whole function itself. After this, when I calculate the limit, what I do is, I combine these two terms together. I combine the root terms together. The denominator h is common to both of them. I separate them. The derivative of this can be calculated, and you know by heart the answer of this. This is 5x cube, x raised to 4. And the derivative of this is half x raised to half minus 1. That is 5x raised to 4 plus half x raised to minus half. So what's my conclusion from here? If I want to calculate derivative connected by a plus sign, each term directly find the derivative. So here is my conclusion. If f of x is x raised to 5 plus root x, directly I can calculate the derivative. Apply the formula on x raised to 5. So 5x raised to 4. Apply the formula on root x, that is x raised to half. Half x raised to half minus 1. So I can directly apply the formula on each of the term. Same would have been the case if it would have been minus sign. So I can say whenever the function terms are connected by plus sign or minus sign, the term by term apply the formula and get the derivative. You don't have to do such a big process every time. You need to only just remember, if two functions are connected by plus sign, find the derivative of u, find the derivative of v, add it. We also saw just before, if a function is connected with a constant, a function is multiplied with a constant, when you find the derivative, the constant remains as it is and you need to find the derivative of u. So addition and subtraction, term by term you have to differentiate with the plus sign as it is, minus sign as it is. When a constant with a function, constant remains as it is, no change to the constant, find the derivative of the function. Now I am going to teach you another notation that we use in derivative, much easier than what we were writing. We were using f prime x, f dash x for denoting the function's derivative. Now there is another way of denoting, because in f dash x, one problem is there. If your constants are denoted by alpha or constants are denoted by another alphabets, it is difficult for us to find out which is the variable and which is the constant. So to avoid this, we have another notation. We write it in this format. If y is a function and you are differentiating phi or finding the derivative with respect to x, that means x is changing, correspondingly y is changing. Then the derivative of y with respect to x is written as derivative with respect to x. What are you finding the derivative? Y's derivative. It is written as dy by dx. Derivative of y with respect to x. Please do not confuse by putting the denominator sign. It is not division. It is a d by dx. It means derivative with respect to x. The change is occurring in x first. Then the change in y occurs. So derivative with respect to x. What are you define? Whose derivative are you finding? Y's derivative. So it becomes dy by dx. Suppose x raised to 5. I want to find the derivative of x raised to 5. What I will write? D by dx of x raised to 5. So you will write directly answer 5x raised to 4. So in other words, if I use f of x and f dash x or f prime x, y and derivative of y both means the same. There is no difference between the two. Function can be denoted by y. The derivative of y, f of x can be denoted by f prime x. It can also be denoted by dy by dx. So there are two ways to notate the derivative of a function. One by putting a prime, another by writing dy by dx. What is the benefit of this? We know the variable. Suppose I want to find the derivative of a raised to 7 x cube. We are a little confused. Which is the variable here? Whether a is variable or x is a variable. It is easily can be understood by the denominator. What you have written is derivative with respect to x. Since x is present here, a raised to 7 is a constant. So a raised to 7 will remain as it is. You need to find only the derivative of x cube. So you need to only find d by dx of x cube. So a raised to 7 into 3x square. Now onwards, we will be using this notation very often than this, because it is easy for us to understand what is a constant and what is a variable. The variable is x cube here because derivative with respect to x. A raised to 7 is constant. In other way, suppose I have written d by dA of a raised to 7x cube. In this case, x cube is a constant and a raised to 7 becomes a variable. So x cube will remain as it is, d by dA of a raised to 7. So this became x cube into 7 a raised to 6. So depending on the variable, we have to decide what is a constant and what is a function whose derivative we want to calculate. Now we shall see what is the derivative of a constant. So I've taken function as